starting section 6.1. We talked about stuff. Most of it was on the whiteboard. We'll get it back here for anyone who's watching the video later. All right, 6.1. They've written it down. We have formulas. Question: blue or red? Those of you looking at the whiteboard, which version of formulas is good for this one?
Red.
No.
Blue.
Blue is a cute.
But why? Thank you for at least saying the color. Why is blue better?
It's easier, and this is the first problem.
Yes. And why is it easier? What can I plug in?
This two angles.
Two angles.
I have two angles. I have two angles. I have two angles. What two angles do I have? Well, let's think about this. I have C and I have B. So does it make sense that maybe I'm going to be doing A over wait? Why is she using that if she has C and B? Let's think about it. Let's think about it. No, I'm coming right back to you because I think you see it. But give me 1 second, okay? All right, what do you see, Noah?
Oh,
Why am I using this?
Because you can just solve for A by adding those two and subtracting 1 from 1.
You're exactly right. Let's see if they know why you're saying what you're saying. He says you can solve for A because you can add those two and subtract from...
180.
What's he talking about? A side or an angle if you're subtracting from 180?
Oh, no. No, side.
An angle, because what do the three angles of a triangle add up to? Oh, nice. So I can always say, given two angles, right? Always. Given two angles of any triangle. Does it have to be a right triangle? No. Hey, snazzy vocab might be helpful at the very beginning of homework. What is a triangle called that does not have a right angle? Oblique. Hey, it's a vocab. Oh, what are you going to do in homework when you are writing things down, when you are talking about an oblique vocab word? Are you going to leave it blank and have Emily take off points?
You're gonna write them.
Why are you going to write it down? Because I'm so mean?
No, so it gets into your head.
Help your brain make connections. With those connections, you'll learn better, right? Faster. Maybe not perfectly, but hey, it at least gives you some place to start, as opposed to, ooh, green check mark, keep going, and you don't remember a thing. Moving on. We all internalize that. Like we heard, we're writing down the vocab. Every single, no, just give me the idea. Oblique, what is oblique? Non-right. Okay, cool, move on. Write it down, though. So when Noah said we're able to get A, he meant capital A. And we can get capital A because given two angles in any triangle, we can find the third. Why? Because A plus B plus C has to equal... So what is angle A, everybody?
30.
Ooh, look at those people that figured out that that's 150 and subtracted from 180 and got 30. It wasn't in the picture, but I needed it. Did I technically have to start there? No. I could have started with C over sine C equals B over sine B. I could have started with C. I don't know, I like going in alphabetical order if I can. On the other side, what am I going to plug in, cool kids?
What? 20 over sine of 45.
No matter whether I chose to go with A first, getting A, or to go with, obviously can't multitask as well as I thought. Regardless of whether I'm choosing to go after A first or go after C first, I'm missing both of them. P.S. I already know angle A because I used this trick up here at the top. In the sense of A plus 150 is equal to 180, so therefore, just in case, 105 plus 45. Just in case you needed it, I already have A. Regardless of whether I'm going after little a or little c, why must whatever I do include this one for this triangle? What did I just write down? 105, 45.
45. Sine 45.
Oh, we should sue. Look at you guys advocating for mistakes on the board. Good job. Good job.
Oh my god.
You know what's the problem now?
Oh my.
You use a pencil, it's not a big deal. Okay, moving on.
No, that's not. It's too light. Anyways.
Moving on. I never pretend to be perfect. Can we go back to the question? Because I'm guessing 1/3 of the class was like, ha 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 ha. Okay, coming back. I know you too well. Coming back.
That was true.
Not me.
Ready? Whether I was going to go this route or this route, why would I have never have gone this route for that problem? Why am I going to include him no matter what? Ryan, what do you see?
Because you're missing the sides for A and C, and you need the side in order to solve.
In order to solve an equation, I need one unknown, usually unless we're talking about complex numbers and there's like categories. Otherwise, we're just going to get this dude. I only want one unknown. So in law of signs, you got to set equal to something that you know. That makes sense, right? Like I want numbers here, so I'm setting that equal. Or I want numbers here, and I'm setting it equal. I couldn't have done that with that because I didn't know A or C. I didn't know A or C. Blessings be upon you. All right, so
Gracias.
if I want to, de nada. If I wanted to solve for the other guy, I could solve for the other guy pretty easily because I could just say, well, what about this guy? Couldn't I have taken this exact same proportion and set it equal to, all right, here's the 105. Couldn't I have done that? So how am I going to solve for both? Natalie, what did you say is so nice about setting it up like this? Yeah. So can't I just go ahead and say A is equal to 20 sine of 30 all over sine of 45. And C is equal to 20 sine of 105. I'm moving in 5, 4, 3, 2. Already passed. So, if I was a really mean pre-cal teacher, I would say, that's unit circle. That's unit circle. That's unit circle. That's not. But I bet if you use one of those double angle formulas, we could get to the 15 that's away from 90. But, instead, why are we all going to be like, whew, what am I going to tell you to do? I told you it was the calculator chapter. Get that calculator out. Let's throw it in. But let's talk about the most, we're in honors pre-cal, efficient way to plug it in. What's the most efficient? Wait, guys, I'm warning you for all of chapter 6. For all of chapter 6, we're getting to our calculators. The calculations will get involved. You can put other words in there, but we'll just say right now involved. They're getting involved. If they're getting involved meaning there's lots of numbers, there's lots of stuff going on. If we're trying to make it, the final answer, be as accurate as possible, we're not going to want to do like, ooh, let's do a calculation and then another calculation and then another calculation and then another calculation. We're going to want to put it all in at once when possible. Why am I saying this? The most efficient way to put it in is to throw in this and say, hey, am I in degree mode? No, I'm not. You probably aren't either. Go get in degree mode. Put it all in at once. 20 sine of 30 all over beep, 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 sine of 45. Not 46. One calculation, one answer. There was no rounding upon rounding upon rounding. I have my final calculation. What's that?
I forgot how to do that fraction bar.
Oh, don't worry. I got you.
Alpha, Y.
They got you. Even better. Alpha, Y equals enter. In case you needed the enter. Alpha, Y equals enter. Is there more stuff up there? Oh yeah, the F1, F2, F3, they're totally calculations. Hidden menus all over the place. Alpha, Y equals, alpha window, alpha trace, alpha, how many buttons are there? I don't even know. Calc?
Yes.
Alpha graph? Anyway, alpha graph, there's nothing there. Everything else, there's stuff. Go look. P.S. This one does a fraction. I don't even know what that one necessarily does. Oh, it's a mixed number. That makes sense. Anyway, fraction, and then guess what? This one says, I have a decimal, but WebAssign wants a fraction. That does math frac. That's kind of cool. But you can also just do math frac. That's easy. What else do we got? We got, basic stuff like an absolute value or a summation or a derivative or integral, that's calculus, or a log base or a special root, or that's fun. We also have, I don't know, that's matrices stuff, we're not there yet, but we also have, ooh, what does that do? That says, hey, I can plug in stuff like y of, and I can plug in, I don't know, I want f of 7. Okay, cool. Let's do y of 7. Woo! There we go. Anyway, that's the right answer, 14.14. P.S. If you just typed that whole thing in, would there be any purpose in copying and pasting it for the next one? Maybe, because all you gotta change is the 105, isn't it? Oh, snap doggy dog, just go change it to 105, and then you have the other answer too. I copied, I pasted, no, I just went up and hit enter. And now I have my other answer too. Ooh. Dun, 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 dun. I don't know what's coming up. Oh, look, it's the head. That's cool. All right, so final answer is 14 point. What's WebAssign normally do? Is it 2 decimals? I like 3. That's what I like. 14.142. I'm doing it. 14.142. Are there any units? Nah. All right. Are we ignoring the directions? Yeah. And then this one was, who has it in their calculator? Because they're doing it with me.
7.320.
Wait, is it 320 or 321? Those are
Well,
different.
there's 3205.
Ah, and if there's a 5. 5 or higher, you round.
I did not see
Oh.
that.
You round up.
Yeah, I was trying to do.
Hey guys, how we doing? Can we use our calculator? Noah, what's up?
Mine's I put it into a fraction, and it's 221,542 over 8,109. And I don't know how do you like convert it to decimal. They put it into a fraction.
Hit math. Oh, no, that's not gonna work. Never mind. Quit. Interesting that it did that though. Are you in? You can hit alpha y equals number 4. 4 says fraction, decimal, decimal, fraction. Might just depend on the programming. Maybe yours is more up to date or less up to date than mine. I'm not sure. Yeah, Ryan.
I know their answer, but the modus degree.
Because of how they gave us the angles. So you guys show off and be like, well, as long as I have 2 angles, I can do anything. Go. Go. Set up the formula. As long as you have 2 angles, you can do anything. Set up the formula.
Yeah, what is that? That's degrees. Degrees, inches.
Like I said,
And then Ryan's like, it's like, dude, I know I screwed up.
So you just multiply basically.
This is so fun.
It's just 0.20 times 4. So 8.
So,
Ryan. No, 20%. 6. Oh, right, isn't it?
I forgot it.
Do you know how to do that rotation?
83.2.
You think of a degree as an hour. What would you do if you had 20 minutes out of an hour and you needed it to be hours?
There's like a button.
Oh, for 45?
The fraction. Just in case you're a little bit stuck. Now, first of all, there is, Paul, I'm just thinking it might be your question. Just in case you're stuck. Joy and Baron, we good? We're paying attention? Just in case you're stuck. This is 20 minutes, right? Do you remember degrees, minutes, seconds? That was a way of like splitting a degree. If it was like the world and longitudes and latitudes, we need to get tiny fractions of a degree because a degree is huge. Think of, if worst comes to worst, remember, this is just a silly trick, but you can think of a degree they're not the same thing, but they kind of are. Why? Minutes and seconds. How many minutes is in 1 degree? Like it is in an hour? 60. 60 minutes in 1 degree. So if I have only 20 minutes, that's not a whole degree, is it? 20 minutes is what fraction of an hour, aka what fraction of a degree? Yeah, it's 1/3, right? So if you don't want to go find the degree mark in your calculator, which is there, there's a subheading called angle. Find the right blue or green and pick the button that says angle right above it, and you'll find the little minute mark. If you don't want to go find that, you can also just call this 83 1/3 degrees, can't you? You can also just call it 83 1/3 degrees, or you can go find that little minute mark. There's an angle menu. Who found it? Is it blue or is it green? It's blue. And what button? Apps. Blue apps. Second apps. You can go find a little degree mark and be like, boop, there. Oh, no. Well, yes. You have to use the degree and the minute so that it knows what you're talking about. But you can also just call it, I'm lazy, 83 1/3. Paul, was that your question? No?
It did not work.
You have to use the degree button 2, 3, and otherwise it's confusing.
Oh yeah,
No. Don't. Well, I guess you could do minutes as long as you put it over 60, right?
83.2.
Yeah.
5,000 over 60.
No one else get one.
Alright, let me plug in what I would have done and let's see if it matches what you would have done. But there was no picture. Some of you made the picture. That's okay.
Yes.
Some of you were like, I'm just going to match the letters. That should have worked too. The question is, would you have had your little A be first? Wait, about the formula or about something in the future?
No, I'm like trying to plug in the numbers. to
Oh.
find- Oh. So when you plug in the A,
Just in case.
when you plug in A into your calculator, you get degrees of A.
If you're doing the minutes, you have to show them what's degrees and what's minutes.
Yeah, but
Otherwise,
like when you press enter and then it gives you the number.
that's a ratio. That's an opposite over hypotenuse. So you're out of the angle and you're talking about the triangle and the ratio formed. So the answer isn't degrees or radians.
Oh.
That was inverse trig. Does that kind of make sense? Sorry, just in case you didn't follow the math, and then we'll get back to Natalie's question. Just in case you didn't follow the math, I'm putting this little multiply on the side because I'm literally undoing division. I'm doing old-fashioned algebra. Some of you, it came naturally, and some of you are like, wait, how'd she do that? I'm just moving it to the other side. That's all I'm doing. I'm just getting A by itself with a quick little multiplication. And similarly, I'm going to be able to do the exact same thing with, wait, what side am I missing besides little a? Yeah, I'm missing B entirely. So how am I going to go straight over here to 18.1 over, how am I thinking that I should know what B is to plug that in for? What am I remembering?
And 180.
Ah, 3 angles add up to be 180. So I can find angle B separately and then use it by saying it's going to be 180 minus that 83 1/3. Keep your wits about you. No, not 18.1. That's a side. 54.6. Alright? I'm going to go do some calculations. I'm just setting this all up. Are we okay?
I have one question.
Yeah.
So I set it up to the 18.1 over sine of 54.6 is equal to A.
over sine of 83.3.
Okay.
That's how you did it.
Cool.
Then
0.333 or just 0.3? Okay. Okay.
And then, wouldn't that get you A? And then I don't understand how you're getting B.
Well, I can use the exact same. Remember, to get B, I could set it equal to like a new thing I got with nasty decimals that I have to make sure I try not to round, or just set it equal to the one with the nice numbers I already know.
But since you don't have like the big angle B, how do we?
Oh, well, I don't yet, but with a quick subtraction, using that 3 angles add up to 180,
Yeah, I forgot.
that's what you missed. Yeah, that's what you missed. All right, so here we go. I don't need B yet anyway, so I'm going to go ahead and, whoop, there it is, and clear that guy out. Shoop, there it goes. There's a fraction. I can do my 18.1 times sine of, here comes my 83 and 1/3. You guys see how I'm doing it? I'm not going to have to go find a minute. 83 and, you can do a mixed number with a plus. Does that make sense? 83 and a third? 83 plus a third? I'm just being lazy. All over sine of 54 point, I don't know, 6. Double check, is your side my side? Is my side your side? Ready, set. Sorry, it's not showing up. There it is. Go.
Yeah.
The degrees of minutes.
That's what I got.
The degrees minutes should not have made a difference. I should have been able to do the exact same thing, but if I was doing degrees minutes, I would have needed to go find, you guys found it, second apps, the degree mark, and then I would have put my 20 with second apps, go find the minute mark. Same thing. But for C, well, for C, I'm going to have to go ahead and do 180 minus, and then I have that 83 and a third. Once again, I'm just lazy, and 20 over 60 is easy. And then I also have that 54.6. Take all those degrees away. What do I have? Ugh. Now, do you see how I'm doing tricky things? Like, they're not really tricky, but you guys know you can do this, right? You're going up and you're hitting enter and it copy and pastes it, right? You check that? So could I try to do this exact same formula I did just a second ago? Because I used the exact same little c over big C, right? But instead of this whole 83 and a third, would it work if I go up and say, I want you? Ooh. You go up, you hit enter, and it'll copy and paste. If worst comes to worst, the other way of doing that, if your calculator gets mad at you, is you can do a couple different things. First of all, you can hit, do you guys see that there's this little check it, watch my buttons, up, 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 up. Second, negative. It says, hey, go grab the guy right above. That's one way. ANS stands for the answer right above, whatever number you just got. But do you want to see something else that's really, really cool, especially in really, really tricky problems? You ready? Do you know how you have this big number? And you want to use that big number somewhere else? It's like, I hope the copy-paste works, and it doesn't always sometimes, depending on the complexity. You can say, I want to make you, stow you away as a letter. Guess what's going to happen every time I put B now? Which is why Mrs. Leon would sometimes have chemistry people put Avogadro's number in as A on their calculator. Stow it away. So if you have a number, you can hit the stow. Hitting stow says, make that answer a letter. Make it whatever letter you want. Then what I could do is, I know all these things you learned. I can go grab that cool fraction and I can say, hey, Mr. Fraction, I'm just going to put angle B in because guess what? I have angle B. I can put in alpha B and say, I want you. Dun, 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 dun. Fun things.
That is a tub, I got it right.
Fun things. Fun things. In doing all the fun things, though, I kind of lost my right answers. Can somebody help me with what the right answers are? And then we'll go over questions. What was that? I lost my little A.
22.055.
And you rounded right?
Yeah.
Yes, yes, yes.
And what was B?
14.87.
And what was angle B?
42.06.
Ryan, go ahead.
I was gonna say, like, when you're inputting stuff on the calculator, but you don't want to like get rid of the stuff to the right of it, how would you like input it?
Oh, you have to throw in that little, like, let's say that I wanted to put something in between the 18.1 and the sign, right? Right now it's going to override it. My sign's going to disappear. But if I hit second insert, second delete, it'll put it in and be like, you can add whatever you want.
Oh, okay.
How do you do the copy paste thing?
Copy pasting is if I want to use that dude. See where my cursor is? Let's say I want him to go there. I go grab him, or I go grab anybody, and I hit enter and it'll throw it in.
Oh, okay.
But there are times when the expressions are so complicated that might mess it up, and there's no undo button. So I kind of like storing it as variables, but the copy paste usually works. We've been playing with our calculator. You guys okay in at least plugging in the answers?
Yes.
Do you see how we're trying to be efficient with our calculator though and learn some tricks along the way? Cool. So far we had two angles. We had a different two angles, but whatever. That whole 180 thing is quite nice. So what about no bad words? Call the donkey. It's okay. No bad words. Do you remember in geometry you weren't supposed to use this guy? Most geometry teachers would be like, yeah, don't use that one, right? To prove things like congruency. SAS was great. SSS was great. ASA was great. AAS was great. This guy wasn't? I know. Okay, I know. Guess what? This results in. That makes this. Now, I'm not saying we're avoiding it. We're not avoiding it this year. All we're going to see is why you couldn't use it in geometry. And then we're going to figure out, but what can you say? You ready? This is the tricky one. Like we're there. We're to the tricky one. We're on slide 4 and we're almost done with notes. This is the trickiest part of homework. You guys ready? Okay. Ambiguous case. What have I put in parentheses? Painful case. Why have I put in parentheses? Painful case. You guys okay if I do a quick little trig timeout? What if I was to say something, I know, I said no more unit circle, but just, you can do it. What if I was to say solve, it should be fresh in your mind, for all the thetas within, you're welcome, 0 to 2 pi, for which, this is helpful, this is important for why this is tricky, for which the following is true. Sine of, let's use a capital letter. We're doing triangles now. So sine of, what do you guys think we're going to be missing? Oh, let's use this one. We're missing B and C, right? We're missing angles B and angle C. So let's pretend that we figured out that sine of capital B is equal to 1/2. Let's pretend. Sine of B is equal to 1/2. We're going to come back to that in just 1 second. But let's go ahead and, I'm not even going to fill this in yet. You can be setting up your notes. That's cool. You guys realize I'm just giving you an arbitrary geometry triangle every time, right? Super basic general triangle, whatever, ABC. What would happen if you started trying to plug into this? First of all, which formulas would you be using? Blue or red? Right? You're missing an angle. Which angle do you think we'd be starting to solve for first, based on the letters that we have? Yeah. So, sine of unknown B all over, yay, I know you, equals, that's not a 13, that's a B, I don't know him. There we go. Sine of 20. So far, the math doesn't look that much more complicated than the ones before, right? Natalie, what can I do? You're the one that rocked this out. Why would I set it up like this? How can I solve for B? Yeah. But what's different all of a sudden? For everybody. What's different? Why isn't it as easy as the ones on the page before or the page before? It's not just a variable, it's a sign. Can we come over here for a second before we go tackling that? Do you see the dilemma? I don't know capital B. I'm not going to land at, this is B. That I'm landing at, this is sine of B. Okay. Come on. What 2 quadrants could have this as its value? What two angles? No, not even what angles yet. What quadrants? What quadrants would we be in where sine would be positive? Right? Now, any cheater chart backwards? Or people that are like, I know where sine's 1/2 it's at. Where is it at? Well, the square root of 3/2 is what the cosine is at the same place. I want the angle. I need the angle. What's the angle? Pi/6. Oh, we're doing degrees now. Pi/6 is really?
30.
Cool. Let's have fun with this. 30. Are we all in agreement? Sine is 1/2 there.
Yes.
If not, you know, if you looked at your unit circle, you would find it to be 1/2 there. Okay. And you told me sine is also positive here. Why? Because I'm also going up here, and sine is the y value. Up to that, up to that. Why does this show the dilemma? What are we needing to solve for? An angle and a what? What are we trying to solve? What's this entire section? Law of sines, but what are we trying to solve? Sides and angles of a triangle. Can 30 degrees be in a triangle? Yes. Can 150 be in a funky looking but still triangle?
Yes.
We have ambiguity. We have possible ambiguity. We could possibly have more than one way of putting together the information that would be right. There might not be one right answer. There might be two. And all of a sudden, that's why in geometry it was like, no, stay away. Cannot prove congruency with SSA because there were two different triangles with SSA and you were not guaranteed that it was the right one that you wanted. Now here's a dilemma though. I just wrote in there could be two solutions, but aren't there empty blanks before the two solutions? Yeah, exactly. There could be no solutions. Because they could give me an impossible sign. Ooh, are there any impossible sign values? Where sine inverse wouldn't work? 1 works, probably won't be in a triangle. No, it'd be 90 degrees maybe. But anything bigger than 1. Did geometry ever give you an impossible triangle? Do we not remember Mr. Brad? There are times not a possible triangle was a thing. There were times not a possible triangle was a thing.
Oh wait, I remember that.
So 0 would be a impossible triangle or sine of my theta. This is what it's supposed to be. It's going to be no solutions if it's not in between 1 and -1. If I find a sign that's not in between 1 and -1, if I try to do sine inverse and it says nuh-uh, it's probably because it's an impossible triangle. You might have plugged it in wrong, but it's probably an impossible triangle. That could happen, or you'll see, there might be times where there's only one. There's one and only one way to put together information, but this is the dilemma. It's like, which one? And my answer is test both with the givens. Pause, internalize before I distract with Natalie's question. I'm coming. Which one? We don't know until we verify. They might both be possible. One might only be possible. And if you're getting answers, it's not 0. 0 would be you're not getting any answers at all. Any answers? What? Any answers when you, guys, how do we undo a sign? No. How do we undo a sign? Some of you are getting it, but some of you are trying to do something else. The only way to undo is inverse operation, and the only inverse of sine is sine inverse. But here's the dilemma. Sine inverse, is it going to give you both answers? No, it's a restricted calculator function that is built to only give you one. So we're going to have to check, ready, test Because of what's over here. Ha ha ha. You guys know what that means? Whatever that is. Natalie, what was your question?
So, when it's like an interval like 0 to pi, if the, on the graph like it hits 2 pi, do you put 2 pi as one of the intervals or no? Okay. 'Cause that's
Open is what a parenthesis. It's an open boundary. An open boundary is like an open circle. An open circle is like an all up to, but no including. Whereas the bracket is closed as in all up to, and including as in. Ryan.
So when you check that
Ooh, can we do that check and then you ask? Is that cool?
Yeah.
Let's do that check and then have you ask. What are we checking? Well, guys, we're just solving the formula. Whatever. But this time we have to do, ready? Be efficient. Can we do second sign of a fraction and put it all in at once? Yeah, we can. Yeah, we can. Second sign of a fraction. What fraction? Well, the whole thing, which is going to be 5 sine of 20 degrees. You're in degree mode, right? All over 3. Now, hold on. By hitting enter, if we get an answer, the answer is not 0, impossible triangle. If we get an answer, there's at least 1. Whew! All right, we have an answer. It's not 0. It's possible. They gave us a legal bit of information. But we also have to check. You guys see my 180 minus answer, right? Now, Andy, we can copy and paste that guy, right? We can copy and paste him. Or we can second answer him. Or we can make him a letter and be like, I'm going to call him this. Okay, cool, we can call him. Long story short, we just need to somehow check the other guy. And you're like, well, isn't 180 minus a number always going to give you a number? When would that not work? It'll always work. The question is, does it make sense with, oh, it doesn't let me do it, struggle bus. Does it make sense with the other angle? There is an angle established in the triangle. I have to have 20 degrees. Guys, 3 angles in a triangle add up to be what again? 180. How many degrees are still fair game after I think about the 20? No. 180 minus 20 is 160. I have 160 to play with, right? I have 160 to play with. Question, does 34 fit within 160?
Yes.
Does 145 fit within 160?
Yes.
Yes, it's awkward, but yes. This is a 2-case situation. Why? Because both angles fit or are possible within my 160 I have to play with. Sasha, go ahead, kid.
when I put it in, it said I had the main error.
Ooh. Are you plugging in with my alpha y equals fraction thing? Are you using a division sign?
Yeah.
Okay. Are you in degree mode? Okay, let me come look. P.S. The rest of us, we have both B and B prime. We have a both B and a B prime. All that means is we have 2 different B's that are possible. P.S. Once you have B, what do we need to find now? We have A. We have B. What don't we have?
C.
Go find me C using your calculator efficiently. Walk through parentheses. Use your calculator efficiently. You can do it.
So, for B, so each of those angles, like, has to be less than 160, or do you, like, add them together and then that's...
Well, I only have 160, like just by definition of a triangle. To actually get these three pieces to work together, I only have 160 to play with. So as long as this is less than that, giving room for a third angle, it's going to be fine.
Okay, so it doesn't matter how much room is left.
No. Well, if it was 160, like even, it wouldn't work. Because I would have a 0 as my third angle. If it's 159 point, it's going to be an awkwardly, really, really flat, long triangle, but it is a triangle.
So as long as both of your answers are
Less than what's remaining from your initial degree. Yeah. And we'll look at a picture of that in just 1 second because we can see how these are both possible. And there's much deeper studies that have been done on like playing around with it and making it make sense, but once again, you guys are honors. So I'm not necessarily giving you much more besides the, hey, look. What happens with the math? Using what you already know about the trig. As you guys were solving, hopefully trying to solve efficiently, let me make this a little bit smaller. Hopefully I can fit both in the same window. And given what you know about copying and pasting and going back and grabbing stuff, right? Don't I just need to do 160 minus? Wait, why am I doing 160 minus? Because I did 180 minus. So if it helps you guys, I mean, if it helps, we're really doing 180 minus what we already know, which is the 20, and whatever we were given or what we found, which was either this guy, copy paste, right? And that's going to be one angle C, or 180 minus the other possibility, and this will be the other angle C. But we got down using our calculator okay, right?
Yeah.
That's not too bad. Go copy paste, copy paste. We're using the add up to 180. Use your cursor button to go up and get what you want to use with the cursor in the place where you want it to go and hit enter on that number, it'll pop in. Sadly, the second answer thing only works for the one before. The second answer thing only works for the answer before.
Where's the 20 comes? Oh.
20 is what we knew. 20 was an angle in a triangle. Sasha?
Why would there be two angles C?
Because there were two possible angle B's, which I'm going to show you in a picture in just a second. But right now, all we know is the math. When we checked the two different possible signs of this guy, we got two different angles that could add to 20 to make a triangle because of what we just saw. Both of these angle C's are positive numbers. Now I'm going to make them simpler numbers in just a second so that when we take it to that picture over there, we're not dealing with the nasty decimals. Yeah, I don't need them that big. Just kidding. Just kidding. But this is going to be my C and my C prime. I think the picture, Sasha, if what's happening in the math doesn't make sense, hang in there. The picture might. Okay, so can you guys just have the 35? No, let's just forget the decimal. Is that okay? I know we usually round, but let's forget the decimal. Can we take the 34, 145, the 125, and the 14? Can you guys have those numbers ready for me? Is that okay? What do we know? We know. You don't have to draw this unless you want to. You just watch if you want. We have A. B would be, let's see, A, B, C. If I'm using my general triangle, I'm doing A. Oh, I'm doing A, B, C. Yeah, it's okay. We can do that. A, B. Yeah, we can do that. Okay. So give me my givens real fast, guys. I have angle A to be 20, right?
Yeah.
I have side A being what? Is it B that comes next?
Yeah, I don't think it's the same.
Did I give you A and B?
Oh, no, it's 3, sorry, it's 3.
No, you're okay. But B comes next, right? So B
Yeah,
is
B.
5. A is 3. If I'm thinking of my generic, I go A, then I go B, then I go C. This is assuming it's an acute triangle. Acute triangles are ones with all less than 90 angles, right? Or 90 degrees. So here's, here's my A. Here's my B. I'm calling this 5, which means I'm going to have to split that up into like 1 and 2 and 3. That seems fairly even to you guys. Is that okay? Fairly even? 1 through 5?
Yeah.
Okay. And now here's the question. I need to somehow get to this 20 degrees, because this is my angle A. Like, I know that I have a 20 degrees. That is solid. But how do I connect the 3? One way is to take, okay, hold on, 1, 2, 3. Let me go ahead and just really quickly, for sake of illustration, because we kind of have time. Oh, I wish I had my stir sticks. That would have been perfect. I'll just use this, and I'll just use this. We'll just... Okay, ready? Do you guys agree that's about 3, right? Based on the units of my 5? Does that seem to be about 3? Right? About 3, okay. If I make this a side. Okay. Here's my side of my triangle, right? It's not great, but it works. Length of 3, true? What's one way that I could connect to make a triangle hitting that 20 degree with 3? Okay, what's one way this could connect? Has to hit here. No, because it's too long. My 3 doesn't fit, right? What's one way I could hit? One way I could hit is right here. Do you guys see it? One way, my side is hitting. One way I can use my length of 3. One way I can make my length of 3 to hit is by coming into an acute angle, and that's that sine inverse that you find. Wouldn't this make a triangle with a length of 5, a length of 3, and an angle of 20 over here? Do you guys agree? And that would be my 1, 2, 3-ish. Right? That's a triangle. Because I don't know how long this is. They didn't tell me side C. Side C is an unknown, so when I'm going to solve for this one, side C is going to be something little. C equals something small. I don't know. I'll find it in a second. I'll find it with what? Guys, what was the little angle B that we got? This is with angle B being...
14, I think. Oh, wait, no, that was for C.
30 something, right? 30?
34.7.
Okay, and we just said just to make it easy, right? 34 something. True? Okay, yeah, I mean, it's about a 30 degree. That was pretty good approximation. I had my 3 and there we go. Okay, but what's another way? Now, we also found the angle C. That's cool. C is equal to, ooh, it's going to be a big obtuse angle, right? What happened when you did 20 plus 34 minus 180? What was my C? Point, da-da-da-da-da, right? What are we missing? We're missing little side C. How are we going to find it? Well, we're going to use our little law of signs and say, well, we have C over, well, wait. I mean, we could do all that jazz. Okay, I guess I'll do it. C over sine of, I could just say big C, because you guys could name him a letter or go copy-paste him. You know who he is. Equals, and we have little a, which was 3, all over sine of a, which is 20. You guys are just going to throw this on the other side. Can someone do that for me? Go throw that sine C with the 125 one and go find me that little C. But as you do that, I'll come back to you in a second. Find me that little C. As you do that, over here, I also have an A. I also have a 20 degrees. I also have a 5. I also have a 5 like I'm supposed to. A 1 and a 2 and a 3 and a 4 and a 5. But what's the other way that I can hit that 20 degrees besides coming in? What else can I do?
Going out.
I can go out.
Is that where at one point the C is larger and then the other point is super tiny?
Exactly.
So the
One way says I have 3, but I go out. The other way says I have 3, but I go in. And that's why we couldn't prove congruence in geometry. We can still say things, but sometimes we're like, well, we don't know based on what you gave us. There are 2 different ways this can happen because this little guy can swing in sometimes and swing out. Not always, but sometimes. Ryan.
So is the C the only one that has 2 different values? Like
No. B does too, right?
Oh yeah.
Because I don't know either angle, and that's exactly why it's a dilemma because, not C double prime, sorry. I'm in calculus right now. We're still in pre-calc. We have one angle. Or I guess we probably have one angle, but we're missing 2. And so we can change that whole shape of the triangle because we don't know 2 angles.
Oh yeah, because if C changes, then.
And so when you guys were solving, do you have these other angle options for me? What was the other angle be? 140 something, right? 145 point something. And what was the other angle C? It should be tiny.
14.
They don't add up to 180, but if you put it with 20, they do.
Where's angle B and where's
Angle A, B, C.
Oh, okay.
This is B prime, C prime. Versus B, C. This C should be tiny. This C should be big. What'd you guys get when you plugged in with this one using the 125? Oh, come on. Some of you are efficient at that calculator. That would have been easy. No? Am I going to go beat you?
No.
Well, you don't have to draw it out. You just pair them together. So this is all one case. This is like case 1. Keep them all together. And case 2.
Wait, yeah, we plug it in with the.
Case 1 is like using the 34, using the sine inverse. That's case 1. Case 2 is using the 180 minus. Do you see what I mean?
B and C and then B prime C.
Yeah. And I just kept them together. Did you get it, Ryan?
On the when C is equal like 14, then it's 2.23.
What is that?
Wait, when C is equal to 14?
Yeah. Oh wait, I saw it for the wrong side.
I think you have the other one. I think that's right, but I think it's for the other one. It would make more sense, I think, for that one. But let me double check. Because all we have to do, guys, is our alpha y equals, I don't know what I just hit, but it worked. 3 sine of the 125 guy. Go find him. He's right there, 125. Copy, paste, all over sine of 20. It's okay if you were all paying attention. I just thought somebody was tracking and might be able to do this a little faster. And this would be for the 14 guy. So then for the 14 guy,
Yeah, the 14 I think is 2.
oh, not delete. Yeah, so the 2.234 and then 7.163.
Yeah.
And it makes total sense if you draw out the picture. You don't have to draw it out every single time. That would just be little c prime. It's case 1, it's case 2, and it's like it's ambiguous. Why? Because there are 2 different options. So what's WebAssign going to have? Boxes for you to fill in if there's 2 cases. And if there isn't 2 cases, it'll just like you put D and E for the second case. And you only fill in the first case. Or if neither of them work, then you put D and E for everything. Well, when is it not going to work? Well, it worked on this one because I subtracted from 180 like I need to do to check the other possibility anytime I do sine inverse. And I found something that fit. But what if, there's a table in the book, maybe it'll be nice. But what if I did something like this? I'm just going to set it up real fast. Okay, I got you. We could do something like sine of B, because I know little b, all over 12 is equal to sine of A, 42. Throw it in your calculator, guys. See what happens. See what happens when I throw that in. And you're trying to do sine inverse, but you're also checking 180 minus sine inverse. Get back here just 1 second. I want to make it look about the same I did over here. Sine inverse, check also. Sine inverse of 12 sine of 42 all over 22 is us looking for B, but we're also going to check also, 180 minus answer, right? What's happening when you're plugging this into your calculator? Second sign, alpha, y equals, got him, 12 sine of 42, all over 22. You get a number. Oh, okay, so it's not 0, right? And what happens when you do 180 minus that number? Oh. What do you see, Johnny? Why was the It was a good Oh, that wasn't. Oh, who was the Oh, Ryan. Man, I thought my ears were better than that. Sorry. Ryan, why the
Because I thought it was like similar, pretty close to the one up the 145.
Yeah, like the numbers are similar, but question, why is 1 not going to work? Nat, what do you see?
Because 42 plus 158 is.
That's not possible! How many angles were left just from him? I only had 138 degrees to play with.
Yeah, so it wouldn't work.
That's way too big. So guess what? This one isn't going to be a B and a B prime. This one is a B and a forget you. Why? Because it's too big. So what is this going to be? This is going to be only one solution. Why? It's only because I checked and I found this one to not work. Now, what if you didn't realize that? Well, no big deal. No big deal. No big deal. If you didn't realize that, you would have just gone to do 180 minus. And question, what should you be subtracting from 180 to find angle C? Shouldn't you be subtracting 42? Right? And when you subtract 42 plus, that gives you a third angle. It's fine. But when you go to do this one, you do minus 42 plus. If you didn't notice it, what's going to happen? A negative. I can't have a negative angle. That doesn't make a triangle. So therefore, I'm just going to say, hey, only that guy, not the other guy, because it doesn't make sense. What's the one thing that we didn't see? What if you did sine inverse and it said undefined error? You just say, oh, cool. It's not a possible triangle. And you move on. As long as, Sasha, right, you're making sure you're putting that all into your calculator in a way that's accurate. I'm going to write this on the screen and we're done for the day. Natalie, what's your question?
Yeah, will there ever be a time where it's like the B prime is the only option? Or like, will it always be like this?
No, because the acute angles are going to always fit. The obtuse one is the one we're not sure about. Does that make sense?
Yeah.
And it's all, like, if you guys look at this, do you see the 22?
Yeah.
That 22 couldn't swing in. Like, it only works going out and not coming in if you kind of think about it that way. All right, I'm going to go label it, and then you guys are having your last example for today. C equals C prime is a no-go. I can't have a negative, so B prime was a no-go. All right, cool kids. 3, 2, 1, get out of here. Bye.